Okay, guys, we're going to be doing neural network and machine learning all in one. Before we start, this is the data set you need, the train and the test. And then as you know, you're going to need to drop a lot of irrelevant columns, which creates a problem for both machine learning and deep learning because it creates bias, but you have to drop irrelevant columns. The solution to that is actually hypertuning the parameters. Whether you're deploying a model on GCP, Azure, or IBM Cloud, you'd be using TensorFlow or scikit-learn, whether you're doing deep learning or machine learning. Unless you're on AWS, you can use SageMaker, which you still have to do hypertuning, parameter tuning jobs as well, like I have done in my other video, which better addresses that. Check out that video if you want to know how to do it with SageMaker. But we will not hypertune the parameters in this video. I'm just going to show you. Okay, so import your train and test. And don't forget to import all of these libraries. Okay, you're going to drop all of these columns for your train and test. Don't forget axis equals 1. Don't forget to fill in A equals 0, all of that. Do your label encoder right here for both your train and your test. This turns everything into a number. Same thing with the nons. It fills in A with a neutral number, 0. Okay. X equals lone, everything but lone. Y equals lone. Train test split, 33%. NP unique, return count equals true. There's your X train shape. Your test shape, you're going to need to drop a column later, afterwards, not right now. Now we get to the neural network after Keras categories util. Okay, so because the shape is normally for a convolutional neural network, you would enter with dense 1, right? But in this case, it's dense 2 because of the shape. Okay, and then the X train shape is the input shape. Okay, so 10,056 neurons, and then a drop out of 30% with 256 and 20%, 128, and 10% dropout. Flatten, dense 2 activation equals sigmoid because this is binary. Adagrad is our optimizer instead of atom. Binary cross entropy and accuracy. Okay, as you can see, this is the neural network. I didn't really want to keep doing this because it would go on all day to get the. Look how slow it was climbing at 25 epochs. I didn't feel like wasting time. This is why I prefer machine learning for tabular data, as you can see when we do our prediction. Look at that, just out of 5, look at how biased it is. Yes, there is a class imbalance in this data set, but also, this is why I prefer machine learning for tabular data anyways. Don't get me wrong, I prefer TensorFlow and for text data, image data, video data, things like that. It's just tabular data numbers. Nothing beats scikit-learn. Well, if you're on AWS Cloud, you got SageMaker. Okay, so then there's YPred, which is from the neural network, and we're going to evaluate it. We're going to import scikit-learn metrics. DF test, everything but lone. YPred. Now we're going to score. Look at how terrible that thing scored. You see what I mean about bias? Okay, now our Adaboost classifier. Before this, I tried a naive Bayes. You would have thought the naive Bayes would have done better, but actually it didn't. Those are usually my two best classifiers, naive Bayes and Adaboost. Logistic regression, SVM, and all those, the things they taught you in school, those are very not good unless they fit the data. They end up having a very low F1 score all the time. And that's why Adaboost is much better. Sometimes you don't even need to hypertune the parameters. It automatically does good, even if you drop columns. No bias on test data either, except in this case. Because Adaboost bags, naive Bayes is careful what it assumes. Okay, so you guys looking at this? N equals predict the train and then the test, 2 numpy. Okay, as you can see, which is funny, M is the train, right? Look, it was biased on the train set, not on the in set. Now, tell me which did better. 83% accuracy score with a 4% F1 score. I would not say so. I would actually, of course, I would hypertune the parameters. No kidding. This needs a hypertuning. But let's say you were just gonna go with which one predicted better. I would say actually this one because look at the F1 score. It actually got a lot of the positives right in this class imbalance. Accuracy score, in my opinion, like they taught you in school, F1 score is actually sometimes more important. You can have a 90% accuracy score, you can have a 95% accuracy score, but if your F1 score is 0 or 4% in this case, it means nothing. Okay, guys. Don't forget, there's information on the internet to hypertune the parameters. You don't need to use SageMaker, all of that. It's actually very good to hypertune the parameters, especially if on test data it doesn't perform too well. But ironically, this performed better on the test data than it did on the other data, on the training data, which is funny. The data it was trained on. Adaboost is a bagging. The naive Bayes did the same thing too. Okay, guys, I hope you like this video, and be sure to check out my SageMaker hypertuning for regression, classification. I've got tons of those videos. Don't forget to hit like and subscribe.